Okay, I am Dr. Babu, Professor and Head of the Department of Biomedical Engineering, Sri Sanmuga College of Engineering and Technology, Sangagiri, Salem. So in this video I am going to explain about the parts of the arc-line machine. In last video I have explained about the need of the arc-line machine, and we have seen about the older, very old arc-line machine and the advanced arc-line machine. Now we can go for the parts of the arc-line machine. So in that, what are the parts are? 5 pump assemblies, venous cannula, arterial cannula, dual system aortic perfusion catheter, meshed cannula, venous reservoir, oxygenators, heat exchangers, cardiotomy reservoir and field suction, filters and bubble traps, tubing and connectors. These are the main parts which is in the arc-line machine. So arc is nothing but natural blood pumping the blood to the entire body, that is called systemic circulation. Like that, here we are going for the artificial pump to pump the blood. So one is, instead of the arc, we are going for the artificial arc. It is nothing but the pump. Okay, artificial heart is nothing but a pump. In the pump also we are having different types of pump that we can see by and by. Then artificial heart and artificial lung. Artificial lung is nothing but oxygenators. So artificially the blood is sent to artificial oxygenator. The carbon dioxide removed and oxygen will be supplied in the oxygenator. So that oxygenated blood is infused again into the body. So 5 pump assemblies, venous cannula, arterial cannula, catheter, meshed cannula. Okay, these are the some parts. Then venous reservoir. So what is the use of the venous reservoir? Is the blood is collected in the reservoir. Okay, venous blood is disconnected and extracorporeal circuit. By using the extracorporeal circuit, the blood going to the heart will be disconnected and the blood will be collected in the venous reservoir. From the venous reservoir, the blood goes to the oxygenators. In oxygenators also we are having different types of oxygenators that we will see by and by. So the main use of the oxygenator is to remove the carbon dioxide and oxygen will be supplied to the blood. This bulk again infused in your body. Then next one is heat exchanger. Heat exchanger is when blood is coming out of our body in extracorporeal circuit, the temperature of the blood is to be maintained to the body temperature. Then after that only it has to be infused into the body. That's why we are going for the heat exchanger. Then cardiotomy reservoir and field suction, cardiotomy reservoir and field suction, filters and bubble traps. So if any in the extracorporeal circuit, if you have any bubbles, it is to be removed, and any blood component that is to be filtered out. Then tubing and connectors. The tubes which is connected to the aorta, to the external extracorporeal circuit. After that it is connected to the body. So tubing and connectors. These are the some of the parts of the arc-line machine. Next, pump. We are having two kinds of pump, two types of the pump. One is centrifugal pump. Next one is roller pump. Centrifugal pump consists of plastic cones which when rotated rapidly propel blood by centrifugal force. This is the centrifugal pump. Forward blood flow varies with the speed of rotation and the afterload of the arterial line. Centrifugal blood pumps generate up to 900 mm of mercury of forward pressure but only 400 to 500 million of mercury of negative pressure. Hence, less gaseous microemboli. Less gaseous microemboli. The microemboli should be removed from the circuit. Centrifugal pumps produce pulse, less blood flow. That is the centrifugal pump. Okay, these are some of the pumps it is explained here. This is called roller pump. So here we are having the tubing which blood is flowing. This roller pump keep on rotating. Because of the roller, it compresses the blood flow, blood tubing, so that it pushing the blood in the one direction. For example, this is the inflow, and it is rotated in this direction, and blood will be supplied in this tube. So it is roller flow. The roller, 2 rollers are available. The 2 rollers are keep on rotating, and because of the pressure, the tube will be compressed and the blood will be moving forward. So this is the impeller pump. It is rotated and the blood will be moving. It is another type of pumping. So it is called centrifugal pump. This is this. Already I have explained about what is centrifugal pump. The blood will be, because of the centrifugal force, the blood will be coming out to the centrifugal effect. Next one is 5 pump assemblies. A centrifugal or roller head pump can be used in the arterial position, atrial position, for extracorporeal circulation of the blood. Left ventricular blood return is accomplished by roller pump, drawing blood away from the heart. Surgical suction created by the roller pump removes accumulated fluid from the general surgical field. The cardioplegia delivery pump, another one is the cardioplegia delivery pump. Emergency backup of the arterial pump in case of mechanical failure. So emergency backup also available in case of the mechanical failure. These are the 5 pump assemblies. Next, venous reservoir. The venous reservoirs may be rigid, that is hard, plastic containers, open types, or soft, collapsible plastic bags, that is closed types. So this is the venous reservoir. It may be a hard type, plastic container, or collapsible plastic bags, or soft type. Venous bubble trap present. Venous bubble trap will be available, that is present. Provides a convenient place to add drugs. So this venous reservoir provides a convenient place to add drugs, fluids, or blood, and add storage capacity for the perfusion system. So these are the venous reservoir. So up to this we have seen some parts of the heart-lung machine. So this diagram and pumping assembly, venous reservoir. So remaining thing we can see in the next video. Thank you.